In this video, we are going to talk about how you can store information about the room so it gets synchronized to all players in that room. We are also going to learn how you can make specific data visible to players who have not joined that room yet, so you can display them in the room browser. The Photon feature we are going to use for this is called Custom Properties. My name is Eberlei and you're watching the Sky Arena Photon tutorial. When creating a multiplayer game, you often want the players to be able to join different instances of the same game so they can play with their friends separately, or have clan matches, or form a community around specific types of play that, for example, only use one game mode they all enjoy most. In Photon, this concept is called a room. You can create as many rooms as you like, and all the data that players send to each other is bound to the room they're currently in. This allows you to keep bandwidth low, because only a handful of people have to send data to each other at any time. Our previous prototype was built so that all players simply join the same large room. Now we want to expand our game so it supports multiple rooms, which players can create and customize at will. The first screen you see after you've logged into our game is the game's lobby. Here you can choose between different methods of joining or creating rooms. For now, we are going to talk about the Create Room section. We want players to be able to create their own rooms and give them a couple of options so they can customize those rooms to their needs. For this tutorial, we are allowing them to set a name and define which levels and game modes will be played in that room by changing the map queue. But you can easily use this concept to allow players to redefine more complex rules, like what items are spawning in the game, how many lives each player has, or the amount of gravity in your world. A map queue is a complex set of data because you're dealing with a list that has a specific order, and each entry in that list has multiple variables. We want to store the map queue in the room's custom properties so each player knows what map and what game mode to load. However, Photon only allows us to store simple data types like integers and strings, because it has to be able to send all that data to all players. I've created a map queue class that defines several methods to transform the map queue from a list to a string and back. This way I can have all the advanced methods of the list types, like adding new entries, removing them from whatever position, or sorting the list, but I can also convert it to a string so that Photon is able to send it to all players. The class is quite simple and I wrote a lot of comments in it to clarify what it does, so I will not explain it much further. I encourage you to try to understand the class on your own. For now, it is enough to know that a map queue is a list of entries where each entry defines a map name and the game mode. Once the player hit the Create Room button, we process all the data that the user customized, the server name and the map queue, and tell Photon to create a room with that data. This is where the custom properties come into play. The function Create Room in the class Server Options takes the name and map queue we defined before and creates a Photon room with them. The custom properties are defined in the Room Options object that we have to pass to Photon's Create Room method and are stored as a hash table. You'll notice that we are using Photon's own hash table implementation instead of the default one. This hash table was custom made so that it can be synchronized over the network more easily, and it also makes sure that it works across all platforms that are supported by Unity. The key for the hash table is of type string. I've created a helper class with string constants for all the room properties that I want to set. For one, this ensures that I don't misspell the room property names anywhere in the project, but you also see that the constants are just 2 characters long. Photon recommends that custom property names are as short as possible, and by using const helper strings, I can name them properly and still use only 2 characters per property. We define properties for the map queue, the map index, which is the index to the entry of the map queue we are currently playing, red score and blue score to count the flag captures of each team, the current map name, the currently played game mode, and the skill level of the player who created the room. This is used for matchmaking, and I'll explain more about this in the matchmaking video. The custom properties for each room can be accessed by all players who are in this room. However, we sometimes also want players from the outside to be able to see some of the properties, in order to display them in a list or use them as filtering options for matchmaking. By default, custom properties are not exposed to outside players, so we have to tell Photon specifically which custom properties we want to give access to. This is done by setting the custom room properties for lobby array. It's a simple array of strings, and we just have to define the names of the properties we want to expose to the outside world. In our case, the current map, the current game mode, and the skill level. And finally, we can give all the data over to photonnetwork.join or create room and let Photon handle the creation of the new room. By calling join or create room, we tell Photon that in case a room with the same name we are using already exists, we simply want to join that room instead of creating our own. We could also call photonnetwork.createRoom here. If a room with the same name exists in that case, we would have to implement an onPhotonCreateRoomFailed method in any class to be able to react to this event. In fact, Photon sends out lots of callbacks for all sorts of events. In order to keep all the Photon events in one place, I've created the class Multiplayer Connector. Photon uses callbacks because most events take a little bit of time to reach the server, do what they're supposed to do, and return with whatever answer the server came up with. When writing a multiplayer game, it's not as easy to just do stuff. You always have to take a small delay into consideration. For example, if you start the game and click Create Room yourself, you notice that after a short delay the first map in the map queue is loaded. But there's nothing in the Create Room method we used earlier that loads the level. This is all done in the callback onJoinedRoom. There is also a callback onCreatedRoom, which is called before onJoinedRoom. But since hosts and players need to load the map the same way, I've put the logic to load the first level to onJoinedRoom. The onJoinedRoom method is quite simple. We just try to find out which map is currently being played, and then we load it. But you'll also encounter a small quirk. We set photonnetwork.isMessageQueueRunning to false. This tells Photon that it should hold off any incoming events until we tell it to resume the message queue. We do that because during a level load, Photon is not able to handle incoming events and they would simply get lost. So for example, if the server tells the client to create an object, but the client is still loading the level, the object would not be created and the client would be out of sync without being aware of it. A little bit further down in the callback onLevel was loaded, which is called by Unity by the way, not Photon. I resume the message queue so the client is able to carry on syncing its state with the server. So now that we've created a room, we want other players to be able to join. The first method to do that is to create a big list of all the rooms available and show it to the player. This is what I did in the tab Room Browser. You can find it in the class room-menu-room-browser.cs. If the client is in a lobby, which happens automatically if you don't tell Photon explicitly to not join a lobby, you can call photonnetwork.getRoomList. This gives you an array of all the available servers the client has access to. I convert this array into a generic list in order to be able to sort it more easily. But this is not necessary. Once you have the big list of all the rooms, it's a simple matter of drawing buttons for each room, which in turn joins the specific room once the player clicks on it. You can see that I received the custom properties map and mode from the rooms at the top of the Draw Room List button method. This is possible because I told Photon before that those properties should be exposed to players in the lobby. If we hadn't done that, we wouldn't be able to access the map and game mode each room is currently playing. And that's all there is to the room list actually. One final thought on it though. Because players are usually lazy and want to join a game as quickly as possible, the rooms that are at the top of the list are often the ones that get picked by most players. So if you want to avoid cluttering some rooms while leaving others completely empty, you have to think of a way to deal with this issue. One solution would be to hide the room list completely from the player and use an automatic matchmaking algorithm to put players into rooms. On the other hand, a room list facilitates communities around specific rooms or lets players browse through what different rooms have to offer. So if a game allows players to customize the game rules in their own room, a room browser might be of different use to you. I simply want to show you all the different ways that are available so you can pick and choose what fits best for your game. In the next video, we continue to talk about custom properties. But this time, we use them to handle gameplay data. And we also learn that custom properties can even be applied to each player. I'll see you over there.